Chapter 23, Geologic Time. Section 23.1, Relative Dating. So remember that when we talked about sedimentary rocks are deposited so that the sediments on the bottom are older than the sediments above. They deposit in layers. This principle, along with some others, allows geologists to use what's known as relative dating to sequence rocks, to talk about the relative age of rocks with respect to one another. This can be used to organize all rocks all over the face of the earth, but it will never establish a definitive time frame. It won't tell you exactly what year those rocks were formed, but it will tell you the order in which they were formed. There are certain principles to relative dating. The first is what's known as original horizontality, and this just goes back to the idea that rock layers are deposited horizontally, and so those layers will deposit over time, with the oldest layers being on the bottom. This also means that any folds that occur in the rock had to have occurred after those layers were deposited, otherwise they wouldn't have been folded. The second principle is what's known as superposition, which means in undeformed layers, each layer on the bottom is older than the one above it. This again goes back to the idea that the older layers are on the bottom and the younger layers are on the top. The third principle is what's known as cross-cutting relationships, and this just means that any cuts or faults that occur in the rock had to have occurred after the rock was formed. Again, this seems intuitive. It couldn't have happened before the rock was formed. The fourth principle goes to the idea of what are known as inclusions. Inclusions are just pieces of rock that are contained within other rocks. So think like a gemstone or something encased in a giant rock or a giant piece of quartz. Those inclusions in those rocks would have had to have formed before the rocks formed around them. So they have to be older than the rocks that they're contained in. The fifth principle is what's known as lateral continuity, and this just means that those deposits would stretch out over large areas unless there are obstructions or barriers like riverbeds or mountains. And then the final principle is what's known as faunal succession, the idea that we can use fossil organisms, which we can place in a definite time sequence, and use that time sequence to date rocks. To do this, we use things known as index fossils. These are fossils that are distributed worldwide by plants or animals, or different animals that were all over the world, or different plants that were all over the world. And they're also from organisms that only lived for a brief amount of time, so that they all have a common extinction time. And we can use this to correlate ages between rocks in different locations of the Earth. Due to environmental processes and movements of plates on the surface of the Earth, it's impossible to find a continuous sequence of rocks. Crustal movements and erosions can lead to disturbances. And so these generate gaps in the rock record that we call unconformities. These unconformities can come from different types of breaks, folds, fractures in the rock that can lead to erosion in different parts. And so sometimes it requires the application of numerous principles of relative dating to determine the complex sequences in which rocks were formed and how they progressed over time.